Recording is on.
All right, so this is Chapter 5 of Mastering the Lightning Network. We got the Bitcoin design community here and the Bitcoin dev kit community. And Bosch is going to lead us through this chapter here. And at around 1:45, we'll turn the recording off and have a free discussion until people feel like they're done for the day. So Bosch, I'll turn it over to you. Thank you.
Yeah, cool. So I'm going to cover chapter 5, like Stephen said. So the topic of this chapter is on operating a Lightning Network node. Kind of covers a lot of aspects about running a normal Bitcoin node as well, but I'll kind of gloss over that. I've kind of added some details throughout that weren't currently in the LN book that are a bit more relevant today. Like there's a few things that are a bit outdated and a few examples that I didn't include that exists now that probably didn't exist when the book was being first written. So I've included those, but without further ado, we'll get into it. Hopefully be able to get through this in about half an hour, and then we can open up and maybe do some examples of some Lightning nodes like Stephen mentioned prior to the recording starting, as well as just like have some general discussion. But so to start off, why would you want to run a Lightning node in the first place? So I won't go through all this text, but it's like primarily it's being a full active participant in the Lightning network. Say if you're running an e-commerce store like with BTC Pay or something like that. If you want to earn income, if you want to run a Lightning node and be a routing focused node that earns fees through that way. Particularly for developers who want to like tinker and build services or applications around Lightning Network. Ideally, you'd be running a Lightning node and know the ins and outs and how to do that. Privacy as well is a often touted benefit of using Lightning when you're transacting with Bitcoin. Like I mentioned before as well, building apps with Lightning, an example being messaging apps like Sphinx. I'm not too sure if there's others, but you guys get the gist. And as well for financial freedom, independence, and sovereignty. So the kind of bigger picture of Bitcoin as a whole. So to get started, like there's some cost to running a Lightning node. So to start off, you're going to need a device. So whether that's a personal computer, like mobile, or some dedicated hardware like a Rock64 or a Raspberry Pi. Alternatively, you could also run it on an external host, but I didn't want to kind of cover that too much. I don't think that's the best way to be running a Lightning node. It's ideally you want to run it in a non-custodial, trustless kind of way, and using an external host kind of takes that benefit away, or those aspects away. You obviously need a permanent internet connection, preferably one that's quite stable and fast. Lots of disk space, that's primarily for storing the Bitcoin blockchain, not necessarily data pertaining to a Lightning Network node, but you will need that. Some time, as well as some minor electricity costs. So just wanted to kind of cover the difference between a Bitcoin node and a Lightning node. Just to clarify, like we're particularly going to be focusing on Lightning nodes, but they do have some similarities. So with a Bitcoin node, you don't need to be online 24/7 to receive payments, only to send them. With a Lightning node, you need to stay online to send, receive, and route Lightning payments. And by online, you need to be online 24/7. So we'll go into detail on a bit more of that later in the presentation, but your Lightning node ideally needs 24/7 uptime. Bitcoin nodes store quite large amounts of data, like I mentioned before. Currently, it's about 408 gigabytes, so you need quite large storage device to store that. Lightning nodes only really store like a rough graph of like LN nodes in the network and like some channel data, like metadata, like static channel backups maybe, and a few other minor things that aren't that large in size, so not that, I guess, important when discussing kind of like storage capacities. Hardware failures aren't a massive issue when you're running a Bitcoin node. It's easy to kind of say if you have like a Raspberry Pi and the Raspberry Pi SD card fails or the Raspberry Pi fails, you can just buy a new Raspberry Pi, new SD card, as long as you still have the hard drive or the SSD, which has the blockchain data on it. You can easily reboot that and restore your node. But with a Lightning node, if it fails and you have like data corruption, there's a lot of issues that can happen, which we'll get into detail in a bit more later in the presentation. But like one being an issue with like a a channel peer broadcasting like an old commitment transaction and potentially stealing your funds in the channel. And just something to add as well, most people generally run a Bitcoin node and then they have a Lightning node running on top of that. It's just not always the case, but that's generally how it is done. And it's probably the best practice to do so. So why Lightning nodes always online, like I mentioned before? So channel partners may close channels with you, so they cannot move their funds. So if your node's offline, you're unable to do a mutual close, which is also something we'll get into detail when we discuss channel management later in the presentation. But mutual closes are kind of the ideal situation you want when it comes to closing channels. As well, another issue or another reason your Lightning node needs to always be online is to prevent protocol attacks. Kind of briefly mentioned that before as well, but that's just about like a channel partner submitting an old commitment transaction, stealing your funds in the channel you have with them. So there's kind of some types. I kind of segmented this into two parts. The second part is more like categories, so it's not really necessarily a type. The types I have listed at the top here are kind of just like where you would run the Lightning node. So you can run it on like your home desktop, general purpose computer, dedicated hardware, Raspberry Pi, Rock 4. There's various different other single board computers you can use. Pre-configured hardware, like a virtual private server, like I mentioned before, which is just pretty much using someone else's computer to store your Lightning node. And something that isn't mentioned in the book, but I know there's kind of a lot of discussion around if like mobile nodes are essentially Lightning Network nodes, and like I guess they can be. They're a bit more lightweight and they don't have like as many advanced features as say running your own full weight Lightning Network node. Like they might not be as sophisticated as like mapping out the most efficient routes, and they might rely on like an LSP, for example, like Phoenix Wallet or Breeze or Moon. But I just thought I'd add that in there. It's not covered in the book, but like a light mobile node is essentially still like a Lightning node type. And then the categories I kind of mentioned, which is something that also isn't mentioned in the book, is the different types of kind of Lightning networks nodes that kind of exist in the network. This is kind of some loose definitions. It's nothing really concrete and it's not like a standard, but generally you have like personal Lightning network nodes, merchant Lightning network nodes, and routing Lightning network nodes. And technically they're all the same, but it's just how the individual chooses to use that node and what its purpose is. So the hardware requirements, so you generally want to have like a 2 or 4 core CPU. This is the kind of main bottleneck you're going to encounter when you're running a Bitcoin node. Most of that bottleneck occurs with the syncing of the digital signature verification with the blockchain data. So it doesn't actually pertain to the Lightning Network aspect. But as I mentioned before, most people who run a Lightning Network node run a Bitcoin node as well. You want at least 4 gigabytes of RAM. You don't really need much more. Like I mentioned before, the CPU is the main bottleneck, but like you could get 8 gigabytes. The cost between 4 and 8 isn't a huge difference, but 4 is generally enough. Ideally, you'd want about 1 terabyte storage. HDD or SSD is fine. So that's just mainly for storing the blockchain data, like the Bitcoin node, not necessarily data pertaining to the Lightning Network. SDGs or solid state drives are ideal. They're a lot faster and they'll be able to sync the initial block download, which is just the like initial sync of the network and downloading and verification of the blocks much faster than a HDD. But beyond the initial block download, there isn't a huge amount of benefits. But something to add here as well, just with the storage, which I will also talk about a bit later on when we talk about the different implementations of Lightning Network, is you can essentially use a Bitcoin prune node, which you could limit it down to, say, 14 gigabytes storage, or I think 7 gigabytes might be the minimum. So you might not necessarily need such a large storage device. It actually is quite a big cost, especially if you're going to use a solid state drive. So it's pretty cool to see Lightning Network implementations slowly starting to support prune nodes. Like I mentioned before as well, you need a reliable internet, preferably like 10 gigabytes to 100 gigabytes of data per month. You want a power supply, ideally an uninterrupted power supply, one that's not going to get affected if there's a big power outage. And you're going to need some kind of like backup scheme. That might not be necessarily a hardware requirement. Maybe you use some kind of encrypted cloud-based tool, but there is some hardware components. Say if you want to back up a mnemonic, which your Lightning node has an on-chain wallet, which generally has a mnemonic or a recovery phrase. So you might want to use a steel plate or something like that for that. So to get started, the book kind of goes into like two kind of aspects. So it kind of covers helpers, which is like your pretty standard plug and play Lightning node kind of services like Umbrel, Raspberry Blitz, MyNode, the ones that are a bit more user friendly. I kind of focus on these a bit more for this discussion, as this is mostly Bitcoin design community. I didn't go into too much detail on the command line stuff and doing node management that way, which the book does cover, but not in a whole great detail. So just thought I'd add that in there, that probably going to focus more on the user-friendly side of things for node management. But in the guide, they call them node helper projects. Like it's just pretty much a plug and play node. Many of them come with like additional services outside of the standard like Bitcoin node and Lightning Network node. Things like everything from large amounts of like apps that run various open source softwares, which Umbrel just recently introduced, to block explorers, to privacy services. There's a whole range of things, as well as a whole bunch of Lightning node management graphical user interfaces, which I'll cover at the end of the presentation, which are covered in the book in some detail, but not a whole lot. BTC Pay is like another great example of an app you can run on there. I kind of added here, like I don't mention this in the book, but Bitcoin Core like is a Bitcoin node, and there is certain software you can run on top of your Bitcoin Core node that runs a Lightning Network using your local Bitcoin Core node. So I just thought I'd chuck that in there. That is an option. I know some years ago, I'm sure you guys would remember it. I think the Lightning Power users by I forgot his name had the kind of extension you could just simply download, and it would connect to your Bitcoin Core node running on your local computer, and you could easily spin up a Lightning Network node that way. But it's pretty, it's a dead project now, which kind of sucks, but it was cool back in the day. Something else I thought to add to the node helper kind of aspect is there's like a service called prunenode.today, and you can download a snapshot of the Bitcoin blockchain, as well as it comes with a config file to just set like the prune flag to like 1,000, so it syncs as a prune node. It's just a quick way to get your kind of Bitcoin blockchain or Bitcoin node up and running, so you don't have to like spend a whole lot of time waiting for the IBD. Like it's a bit of trust there. These websites run by the Spectre team, but it is an option, like especially if you're using a HTTP and you don't want to wait like 2-3 days for your IBD to sync. It's a pretty cool tool that I've used in the past, and once it's kind of synced up to date, it's pretty trustless. So this is something to add as well. So do you really necessarily need a Bitcoin node to run a Lightning Network node? Something to add as well, just relating to this topic, is you can actually use different implementations of Bitcoin nodes. The primary one's Bitcoin Core, which I think is somewhere to the 98% of nodes run Bitcoin Core, but there is other ones like BTCD that is mentioned in the book, but I'm not too sure. I think there's some benefits of BTCD for, say, LND. I haven't actually looked into detail, but if anyone knows, feel free to chime in on that. But that was kind of mentioned as a footnote in the LN book. And then the other option is the other thing to mention here is you don't necessarily need a Bitcoin node to run a Lightning Network node. You can run it like in a lightweight fashion, ideally using like something like Neutrino, which is pretty privacy focused, and yeah, like it's a way to run a Lightning Network without a Bitcoin node, but it does like severely limit the kind of services available, particularly if you're running like something with Umbrel. Like they don't come with a Lightning Network node only component, because it makes a lot of the applications that they have like in their app store, for example, not work. Like you wouldn't be able to use a block explorer application or something like that. But it's something to keep in mind. Like so, what I mentioned before about the mobile nodes, like they're essentially like lightweight Lightning nodes. Many of them use Neutrino. So I think Breeze uses Neutrino. I'm not sure if Moon and Phoenix do, but I'm pretty sure they don't. But it's just an example of a scenario where you don't need a Bitcoin node. So something to add. Next thing to kind of consider, like when kind of thinking about setting up your Lightning Network node, is the kind of operating system you want to run it on. So it can run on any kind of POSIX operating system, which is a kind of interoperable standard that kind of makes all the kind of different operating systems like Linux, Windows, Macs interoperable. So it's pretty versatile with Lightning Network. And what kind of operating system you want to run it on? Linux would ideally give you more control over your Lightning Network node, but it will work fine on Windows or Mac. You can run Linux-based shells in both of those operating systems, so it's not too much different. And as well, you can use Docker, which we covered last week when we went through chapter 4 and spun up a Bitcoin and Lightning Network node. So just going to quickly cover the different Lightning Network node implementations. So when running a Lightning Network node, there's primarily 3 or 4 main kind of Lightning Network implementations you may want to choose from, depending on your circumstances and like what features you want. I won't go into detail on what each one has, but the kind of 4 main ones like LND, Eclair, C Lightning, and now there's kind of LDK, which I think Blue Wallet is probably the first kind of major project to adopt that implementation. But primarily, like I think most Lightning Network nodes use LND. I was trying to find some statistics on this, but it seems it's pretty hard to get that. But from what I figured, LND is probably the most popular. So if you're not that experienced this kind of stuff, I'll just focus on like LND based Lightning Network nodes. But yeah, there is also Eclair, C Lightning, which also have like some pretty cool features of their own that aren't available in LND. Standards within these implementations are defined in bolts, which stands for Basis of Lightning Technologies, Basis of Lightning Technology. And they just kind of lay out the kind of foundational things that kind of work across the different implementations, standards. This is just a note for people who are building a Lightning Network node. It's ideally you want to go with, if you are a developer and you're a bit more tech savvy, you'd ideally want to go with an implementation that has a programming language that you're familiar with. Each are written in different programming languages. I think C Lightning's in C, LDK's Rust, I think. Claire's, not too sure actually. I forgot what these two are in, but feel free to chime in. I'm sure someone in the call knows. But yeah, like I mentioned, LND is probably the most popular, so probably the best to go with if you're not that experienced. Config files, so this relates to Bitcoin and Lightning Network nodes. So when you run a Bitcoin node and a Lightning Network node, you have a config file. So for a Bitcoin node, it's called Bitcoin conf. When you download, like say, Bitcoin Core with the GUI, if you just kind of go into your files where like your wallet files are stored, there'll be a file called Bitcoin conf. And you'll be able to set like a wider range of parameters and kind of configure how you want your node to run. And I just had a website here that, where did I put it? Bitcoin Core config generator. So this is just for the Bitcoin base layer stuff. It doesn't really relate to the Lightning, so I'll just quickly gloss over it. But this is a website by Jameson Lopp. It allows you to auto-generate a Bitcoin config file like pretty easily. So this would be ideal for designers who don't maybe have the experience to be wanting to play around with the config file directly and maybe editing it through the command line. You could come to this website, go into all the different parameters like stuff to do with your wallet or mining, debugging, testing, block storage, like where it's stored, how much bandwidth you allow your Bitcoin Core nodes to use. Say if you have limitations around bandwidth usage, you can kind of play around with all this stuff. There's a huge amount of things here, and it'll auto-generate a file based on like stuff you click. So if you like say, turn this off, auto-generates a few parameters here, and then you can save that and just replace the config file that comes pre-downloaded with your Bitcoin node with this one, and it will like have all these parameters set. But if you're not that tech savvy, I would maybe not play around with this unless there's some urgent need to. Say, for example, if you have severely limited bandwidth capacity and you need to lower the amount of bandwidth that your node uses, it might be something you need to play around with. You can also set like things like your RPC password and username, which can be used to like connect to like connect wallets and stuff to your node. It's pretty similar, same kind of concept with a Lightning node. There isn't like a simple config generator like this for a Lightning Network node, but it's the same kind of concept. It has a bunch of parameters you can kind of configure and change. I'll kind of cover a few of them later on in the presentation. There's a few examples that I'll go over. But yeah, just be careful when you're kind of modifying that stuff. It can kind of screw your node up. But yeah, it's fun exploration. So next thing to consider running a Lightning Network node is the network. So I'm just going to cover the cleaner aspect of networking first, and then kind of cover Tor related stuff. So if you it can involve quite a lot of manual configuration on your router to kind of set up a Bitcoin node and a Lightning Network node. Some modern routers have a protocol called UPnP, which makes your network accept inbound connections like pretty much automatically without having to configure ports and set DHCP settings and stuff like that. So if you go into your router and you have that, just turn it on pretty much, and you should be able to have your Lightning Network and Bitcoin node working straight away. There's the ports for Bitcoin Lightning. These are just some websites here that were listed in the book that you can go check to see if these ports are open. So once you've done the configuration or enabled UPnP, you can go see if those ports are open, just to know if your Bitcoin node receiving inbound connections, or your Lightning nodes and your Lightning Network node is receiving inbound connections. Why you would want to accept inbound connections: if you don't have inbound connections set, your node will still run, but you'll essentially be, I guess, leeching from the network. So you'll be not relaying data to other nodes. So once you have these ports opened up, you'll actually be, I guess, supporting the network to some degree. It's not a huge issue really, so it's not like a major thing, but it's a nice thing to do if you have the extra bandwidth and capacity to do so. Like, why not? And it's kind of fun to learn this stuff and learn how these kind of things work along the way. There's a website called BitNode as well. I just had it open up on that other page just here, but it kind of just shows like all the nodes kind of in a live map here. Or you can go on the website and you can check your node. So you put your IP in and you check, and it'll tell you if it's there. And it'll actually, I think, include it in this database. So at the moment, there's 12,500 listening nodes, which are nodes that are receiving inbound connections and like relaying blocks to other networks. But I think that the figure of actual full nodes, or by full node, I mean a node that like fully verifies the rules of the Bitcoin network and downloads all the blockchain data and verifies it, is probably more in the range of like 70, 80,000. But that number kind of varies depending on what kind of source you're looking at. But that's just something to point out why it's 12,000, because I know some sources say larger amounts. So just going on network. So with your Lightning Network node and your Bitcoin node, you can connect to it over Tor. I'm sure if you guys have used, say, Umbrel, you have like a Tor kind of hidden service option. Tor is a lot easier to use to connect to your node. Say if you want to connect to it outside of your local network, it's pretty much as simple as downloading the Tor browser, putting in the hidden service URL that is auto-generated, whether by you or by like your node helper that you've used, like Umbrel, and you can access your node from everywhere and configure and play around with things. Also adds a bit of extra privacy. So particularly if you're like broadcasting your transactions, people won't know your IP. So it adds that. And yeah, like I mentioned, you don't have to go into your router and configure port settings and a bunch of stuff like that. So next thing to consider is security. So like I mentioned before, I'm not sure if I actually did mention it, but Lightning nodes require hot private keys, or they have hot private keys, and that's how they kind of work. The nodes are on 24/7, and they constantly relaying transactions, and every time a transaction is kind of relayed through your node and channel balances shift, new commitment transactions are signed. So you need those keys active and hot to make those to sign those transactions and share them with your parties that you have channels with. So there's a big caveat here that you obviously need some good security on your node to prevent those hotkeys from being stolen, as they're online all the time. It's a bit different from using, say, like a hardware wallet which stores your keys offline, or another mode that stores them elsewhere, like a paper wallet. I'm not sure what other ones you really consider besides a hardware wallet. But security is quite a far-reaching topic. It is covered a little bit in the book, but like it can, it's particularly if you're running like a node, say on your computer, you want to go pretty in depth on like, you know, operating system security. You may want to opt for using, say, Linux over, say, Windows or Mac, which might not be as secure and might leak a lot of like private information about your node. You also want to have like, you know, a good password. You maybe want to have things like an encrypted drive on your computer so people can't access it. Say if you like throw your hard drive away, people can't get into it and quickly access your Lightning Network hotkeys and steal your funds. But there's a whole lot of things to consider here with security that I won't get into great detail because it's pretty off topic, but it's just something to keep in mind that your keys are hot, so security is pretty paramount when you're running a Lightning Network node. And yeah, do not put more money in you're willing to lose for that exact reason. So backups kind of pertain security, but with Lightning Network nodes, like you do get a mnemonic because there's an on-chain wallet that comes with the Lightning Network node. But you have like your Lightning Network channel. They're not really separate wallets. They're kind of just like, it's a bit different. But just for simplicity's sake, like the Lightning Network node has like a Lightning wallet component and an on-chain wallet component. Technically, that's not like that correct, but just think of it like that. But you do have a mnemonic that is used to back up that on-chain component. But that's not enough to back up your Lightning Network node completely. That might be enough to, you know, recover maybe some funds if you have them on the on-chain wallet in your Lightning Network node. But when it comes to backing up like the other aspects of your Lightning Network node, like your channel states and your commitment transactions and other things that we've covered in previous chapters, you generally need something like a static channel backup, which is used in LND and LDK only currently, and it's not a standard amongst Lightning Network implementations, but it's kind of the best thing we've got at the moment. It has quite a few flaws, but it's pretty good. Essentially, it's just kind of backs up the commitment transactions and other kind of metadata that pertains to your channels. But like issues that it has is it needs continuous external backups. So ideally you don't want to back it up on the same like hard drive, say that you've got your blockchain data on, because if that all fails or if someone malicious gets into that, if you have bad security practices, you don't want them to be able to steal your static channel backup as well. Like they're probably going to steal your private keys anyway to steal your funds, but like it's ideal to have this backed up externally. And this needs to be continuously backed up every time your channel state changes and commitment transactions are shared between parties. So that can be a bit laborsome, making sure that backup happens. Something you need to keep monitoring, making sure it backs up and things like that. So yeah, like I mentioned, without a channel backup, if your Lightning Network fails for like maybe for hardware reasons or it's power outage, like there's a whole range of things that go wrong. But if it fails, you don't have a static channel backup, like the funds in your Lightning Network node are essentially lost, which isn't that great. But it's yeah, that's the kind of best option we've got at the moment. Ideally, you want to encrypt it as well. Just thought I'd add that. Like, doesn't need to be encrypted, but if it's backed up, particularly say if you externally back it up in like a cloud service provider, you want to probably encrypt that data because anyone that gets access to that static channel backup can like broadcast the the commitment transactions that are stored there and steal the funds or drain the wallet. Like I mentioned. Sorry?
I just want to clarify with the static channel backup. As far as this is not enough to get your node back to its current state. When you use a static channel backup, I believe it's sort of like sweeping the wallet. You go to all your channels and you force close all of them because you don't know the exact state of them. So the best you can do when using that static channel backup is to force close all your channels and get your funds back on chain.
I think that's correct. Yeah, I'm not exactly too sure if someone wanted to clarify that.
That's really interesting. I don't have anything to say other than that. There's like I don't know, the implications of that are actually interesting. That seems highly inconvenient.
Yeah, but I mean, if you had an off, they mentioned in the book an offsite backup. Imagine making an offsite backup every time your node routes a payment. You're running out of the house with a thumbstick every 30 milliseconds or something.
Yeah, I
But
have some
yeah,
idea.
I was not aware of this trade-off until just recently.
Yeah, I have some thoughts about the backup thing, but I'm gonna save them for a little later because it might be getting kind of into the weeds.
Yeah, we can come back to that topic. That's something that probably worth exploring a little bit more. I know when the book was written, it was maybe things have changed a bit since then, but yeah, I'll keep going anyways. So the next kind of topic I wanted to discuss, which I kind of just gone in these in order that they've been covered in the book, but it pertains to sweeping, which I think does kind of relate to static channel backups. Like you said, like it kind of auto closes all your channels, which essentially is like sweeping it all from your Lightning Network wallet per se to your on-chain wallet or to an external on-chain wallet. But sweeping something you should be aware of if you're running a Lightning Network node. So if you have, like with Lightning Network nodes, you don't want to ideally, unless you're like a routing node or maybe a merchant, you don't really want to be storing a huge amount of funds, like for reasons I mentioned previously, like with the hotkeys and stuff like that. So sweeping, if you're using Lightning Network quite actively, sweeping something you'll probably do at some point, especially if you have a large amount of funds. But there's different types of sweeping you can do. So there's on-chain sweeping, which is pretty similar to what we were just talking about before regarding the static channel backups, where you sweep you force close all your channels all at once, and they all go to the on-chain component or to an external on-chain wallet, like a cold storage type situation. There's off-chain sweeping, where you kind of move all your Lightning Network capacity, keeping it on the Lightning Network, but you move it to another node that you control. So say you spin up another Lightning Network node, and you have an issue with your old node, so you sweep all your channel funds to this new node, but it doesn't revolve like an on-chain component. And then the last one that's pretty popular these days, like particularly with services like Phoenix and stuff like that, is doing like submarine swaps. And then non-custodial atomic switches between Lightning Network and on-chain. Loop's an example with LND and Lightning Labs. They offer that as a service, but that's just a way to kind of like sweep funds between on-chain and off-chain. Uptime and availability is an important metric to kind of consider when you're running a Lightning Network node. It's unlike Bitcoin, Lightning Network nodes need to be on all the time, like I mentioned before. It needs to be on to open channels, closed channels, and monitor protocol violations like broadcasting old commitment transactions. Something that you may want to consider, like if you're reasonably tech savvy, is like testing faults using like testnet coins with Bitcoin. So you might want to set up a testnet node and then go like do a static channel backup and fail that node on purpose, and then go try to recover that static channel backup and just kind of go through the process. This is probably something you'd want to do if you want to run like a large capacity Lightning Network node, like for routing, if you want to like attempt to make fees doing that. But these are kind of things probably worth checking out and being aware of and being ready for in case they happen. Terminal Lightning is a kind of scoring website. It uses like uptime and availability as one of its metrics to kind of determine what a good Lightning Network node is on the Lightning Network. Another thing is BOS scores. It wasn't really mentioned in the book, but I'm pretty sure they were around when the book was written. But BOS scores are essentially the same kind of thing. They kind of score nodes based on a bunch of heuristics, and one of them being uptime and availability. But that's probably one of the most major heuristics you want to kind of look at. And another cool service that they mentioned in the book that I hadn't actually heard of before was Lightning Watch. So a Telegram bot you can connect your Lightning Network node to, and it will send you regular notifications if you're having issues with your node. Say if it like shuts down randomly or if it keeps going online and offline, it will let you know. So it's a pretty cool, like I guess, like more user-friendly way to kind of know if your node's staying online. So Watchtowers is a pretty big topic. It's still pretty experimental. So all it really is a mechanism for outsourcing the monitoring and penalty resolution of Lightning Network protocol violations. So there's two aspects of it. You have a Watchtower server and a Watchtower client. The server is just kind of where the kind of, actually don't know all the details of how the server and the client aspect work because it isn't covered in a whole lot of depth in the book. But essentially, the Watchtowers prevent your channel partners. So like you assign a Watchtower client to your channels or to your node, and that client watches your channel partners. And if, for example, you go offline and the channel partner tries to broadcast an old commitment transaction, and the Watchtower sees that violation, the Watchtower can penalize the counterparty broadcasting the old commitment transaction and essentially sweep all them funds and give them to the party who's not attempting to do a protocol violation. And there's a few services around like that. There's I have Satoshi. I'm not too sure there's many others, but they kind of serve servers you can use to set up your own Watchtower client. Like I mentioned before, with the config files, you can enable a Watchtower within the config file in LND. I know with like MyNode, I'm not too sure if Umble does it, but with MyNode, there's like a pretty simple way you can just like click turn Watchtower on, and that will set up like your own Watchtower client that you can use to monitor other people's channels. But I could see in the future like a scenario where Watchtowers are kind of used as like an insurance mechanism for people's Lightning Network nodes, and like maybe charge a fee, a regular like subscription fee or something to monitor people's nodes. I don't know. There's a whole lot of stuff that's probably going to happen and change with Watchtowers in the future, but maybe it's something we can discuss after the presentation. Channel management. This is like the real kind of like meat and potatoes of running a Lightning Network node. It's the primary task you're kind of going to be conducting when you're running a Lightning Network node. It essentially is like opening outbound channels to other nodes and finding other nodes to open inbound channels to you. That will be different. That will kind of change in the future when things like dual funded channels and stuff like that are a bit more commonplace, and the kind of way you kind of source inbound and open outbound channels may change. There is some like changes compared to the book that are a bit different relating to that topic that I was talking about with like finding inbound capacity since the book has been written. But one of them is like cooperative channel construction. In the book, they talked about it as something that will come about in the future, and I guess it is kind of the future now. And there's services like Lightning Network Plus, which allow you to set up cooperative channel constructions, like you can set up like a triangle, pentagon, various shapes, and essentially like you're opening a channel to one person in the triangle, for example, the next person in the next point's opening channel to the next person, and it kind of creates a triangle pattern. If that makes sense. I probably should have had an illustration here showing that, but essentially like everyone in the triangle or circle or pattern, whatever it is opening a channel with one another, so everyone's getting inbound and outbound capacity. So services like that around, and like I mentioned before as well, like dual funded channels will probably change a lot of how people source these kind of things. I know there was like the liquidity ads with C Lightning that got announced recently, and that's going to be essentially based around dual funded channels, and you can advertise your like liquidity within your Lightning Network node, and people can like rent it off you and use it to receive like inbound capacity and stuff like that, which is pretty cool, but very early stages for that. So going into detail a little bit on opening a channel. So the primary way that people generally do it is they fund the on-chain wallet in the Lightning Network node, and they use that to open a channel with their Lightning Network component of the Lightning Network node. It is possible now to fund from an external signer using PSBTs. That wasn't mentioned in the book, but with LND you can do that. It does save on fees because you don't need to transfer from, say, your cold storage to the on-chain wallet and then open a channel, which essentially is just opening a multi-sig, going into a multi-sig kind of contract with another partner. You can send directly from your cold storage and open a channel directly from that way. But then the channel is still controlled by the hotkeys. It's not controlled by the keys of the external signer. So something to consider when opening a channel is you want to pick your peers carefully. There's a lot of websites like 1ml.com, Amboss, and Terminal Web, like I mentioned before, that kind of rate other Lightning Network nodes. So you can use those websites to kind of determine if you want to open a channel with this person. There's a whole lot of reasons of why you'd want to open channels with only like well-connected nodes and things like that. But there is also reasons to open channels with not so connected nodes, but I'll get into that a little bit soon. You also don't want your channels too small. It's kind of just a bit pointless to do that, especially if fees kind of rise in the future and then like it costs more on-chain fees to close the channel. Like you just won't be able to close it and it just cause a lot of issues. Ideally, you want to like move a lot of funds up there. A lot of people look at like putting funds into Lightning Network channels as locking up funds, but like I think it's kind of the complete opposite. And this is kind of echoed throughout the LN book, is that essentially you're unlocking funds and making them extremely more liquid and portable and transportable by moving them from on-chain to Lightning. So it can be a good thing to move large amounts to your channels. But like I said before, there is security risk to that because obviously they are running with a hot wallet. So you don't want to have too much funds. Like you won't want to put all your cold storage into Lightning. And something to add as well is like multipath payments and atomic multipath payments are significantly improving like LNUX. So maybe this wasn't the correct slide to put this here, but these kind of protocols, which also aren't defined as bolts, but they should be, or they will be in the future, significantly improve how like liquid, I guess, your channels can be. So instead of being able to only send the largest send you can send is the largest outbound capacity of your channel, your biggest outbound node. Sorry, your outbound channel. You can send multiple payments from all your channels to a recipient, which makes your channels much more fluid, and it makes the possibility of making abstracting away a lot of the complexities around channel management, which is relevant to you guys as designers, a lot more feasible. So you'll be able to like, make payments from multiple different channels. But next thing to kind of cover is autopilot. This isn't talked about as much. I remember when Lightning Network first came out a few years ago, autopilot was a pretty big hot topic. But essentially, it's just a automated script that kind of picks channels based on those like heuristics I was talking about, like the BOS scores and maybe using things like Terminal Web. But there's just a algorithmically way that, say, for example, LND will automatically pick a channel and pick a peer and open a channel with them. But there's various differences between the different implementations. LNDs is the probably most well-known and standardized. It pretty much automatically opens channels from the funds in on-chain wallet. You can go into your LN config file and change the autopilot settings. You can change it to only open channels of certain sizes, or like only open to a certain percentage of your on-chain funds. There's a whole lot of variables and stuff you can play around with. But yeah, like I mentioned before, there's also no standard with that. Something to mention about bolts is like they're not as it's not as big of a deal as, for example, like BIPs on Bitcoin. There's a lot of like what would you call it? Features being worked on by lots of different implementations that aren't really getting standardized. There's not many things that are standardized in Lightning, but there's pros and cons to that, but that's probably a topic for discussion for another time. So going into detail on inbound channels. So at the moment, generally, if you open channel with someone, it will just be a one-way thing, unless you use a service to open up a cooperative channel, or you use like a loop-based thing to get inbound liquidity. Generally, it's going to be like a one-way thing. But so in the past, sourcing like inbound liquidity was also always a big issue. It still kind of is, but it's definitely gotten a lot better in the last few years. Like I mentioned as well, just then, like you can use Loopin by LND to kind of receive inbound liquidity on your channels. You can use third-party services like LNBig, Bitrefills 4. I know LNBig, I think, uses like a LN URL channel. So you pretty much pay them like a small fee, and they'll give you like a channel for like 1 million sats, depending on what size you want. And they'll give you an LN URL channel QR code, which you scan, and they'll open an inbound channel to you. The issue with that is that's also one way, so you don't have any outbound to them. But then you can like, I don't know, loop in from maybe another channel that you have to move that inbound liquidity to your outbound side. But there's a whole lot of different ways you can do that. A comment that was made in the book that I thought was interesting was that more sophisticated autopilot software is likely to become a thing in the future. So you could have like requests for paying for inbound capacity as like an automated thing, and set how much you want to pay for an automated inbound capacity in your, like, say, LN config file. And when you do need inbound liquidity, say, for example, if you're a merchant and you're regularly receiving payments, and you run out of inbound liquidity and then you can't receive any payments anymore, maybe you have it set up so it automatically rebalances your channels and gives you some inbound liquidity that you can play around with, some kind of autopilot thing. I could really see that coming into play with like the real user-friendly kind of mobile wallets, but I'm not too sure exactly what's being done there on the technical side of things. So closing channels. So you always want to go for a mutual close. So that pretty much means that you and the other partner both agree to close the channel. They both agree on the most recent commitment transaction, and that gets broadcast to the Bitcoin network. You want to do that for a range of reasons. Like generally, you'll get lower fees in doing a forced channel close or like a protocol channel close. I think that's the only other really variant, but mutual close is kind of what you always want to go for. Ideally, you don't really want to close your Lightning channels. Like if you're moving liquidity into Lightning Network, it's good to kind of just keep it there, unless it's like an incredibly large amount. Say if you're accepting a large amount of payments as a merchant, you might want to move it elsewhere. But yeah, forced closes should be avoided, but maybe necessary. So for example, if your partner's offline and you can't contact them, maybe you get some kind of disagreement and you both like have some kind of no issue with the resolution. Like I mentioned before, you have higher fees. I know with amboss.space now, you can register on your website and register your Lightning Network node and actually include like social links. So that way, if like say you have a channel with someone and they go offline for an extended period of time, you go see if they're registered in Amboss, get their like Twitter handle, and you can just pop them a message and be like, hey, your Lightning Network's been off for a long time. I want to close a channel with you. Can you guys log back on so we can mutually kind of close this instead of force closing it? When you force close as well, you have to wait for the time lock to finish to like get your funds, which I think is 2016 blocks, which is 2 weeks, if I'm correct. But that's another caveat as well to force closing. So you ideally want to always go for mutual closes, but yeah. So rebalancing of channels. So like I've mentioned this kind of previously before, but this is kind of an important thing as well. Particularly if you're a merchant or a routing node, you want to make sure your channels are balanced. You don't want to have too much funds on one side of your channels. If it's all outbound, you won't be able to receive payments, and if it's all inbound, you won't be able to send payments. So there's various different ways you can go about rebalancing your channels. I mentioned before about the automatic autopilot thing, which could be an option in the future. If you route a lot of payments, you need to constantly monitor channel balances. Submarine swaps, like I briefly touched on before, is another option. So you can use the loop in or loop out service that LND offers to rebalance your channels. An interesting one that was mentioned that I wasn't that aware of was circular routing to yourself. So you can send payments within like your own channels. So I think Ride the Lightning is like a graphical user interface that has that. As well, you can wait for payment flows in like the opposite direction. I know there was another one I think that was mentioned in the book about setting, well, we haven't covered fees yet, but it was about setting, if you have like, say you need like a bit more inbound capacity, you can set that channel's particular fees really low, maybe to like 0. So other nodes in the network will route payments through your node because it's more economical and cheap. And essentially that will give liquidity to that side of your channel. And then once you've got some sats back in that channel from people routing payments through your channels or through your node, you can bump the fees back up and resume your normal kind of routing.
Hey, Bosch.
Yep.
Sorry to interrupt here. We're getting pretty close to the hour here, and I wanted to see if there was any, questions or anything that people were looking for help with, or anything like that, before we need to turn the recording off, or before people have to get to their other appointments.
Yeah, for sure. Yeah, sorry, I was going a bit over time there, but yeah, I'm happy to move it over to discussions.
And if nobody has any discussion topics or questions, that's fine too. I just wanted to just check and see if anybody had anything.
Actually, I had one question. It wasn't really covered in the chapter, but we can talk about it either on the recording or after. But I couldn't find anything about if there's any setups for like clustering lightning nodes, because there's this whole issue of, you need to be online all the time, and you also need to have backups all the time. And has anybody ever heard of that? Like, has anybody tried to make like a cluster of LND nodes that, you've got like a couple standbys and an active or something like that?
So it'd almost be like one, say 2 LND nodes, and they're both essentially, connected to the same Bitcoin on-chain wallet. But if one of them goes down, the other one can resume routing, and they kind of share channel states between each other.
Right. Yeah. You would have to also share you'd have to be kind of constantly, sharing the, like a live backup. This is like other clustered software kind of has a way to, if they've got a database, for instance, they share a database, something like that. And then the database is also clustered. There's ways to do that.
That'd be very interesting.
I saw a presentation on someone doing this like almost two years ago, but I forget who it was. It was at like BitDevs in New York in like March of 2020. But they were exactly what you're talking about, like having kind of splitting up what a lightning node is into the kind of the front facing thing that is kind of ephemeral and it's fine to fail, and like a shared database that needs to be a little more persistent.
Oh, interesting. I'll do some more searching. I did a little Googling, but I didn't see anything, so I wasn't sure what the state of the art, because I assume they mentioned these liquidity providers that are running really big clusters of nodes, and I assume they must have some secret sauce behind there to keep those things running up all the time, and not to keep the backups and everything, and be secure. So
yeah, because if you're running it on an institutional level, then the cost of a failure is extremely more damaging to you at that point.
Yeah.
Just with the scale of money.
Yeah, not even just potentially risking losing money if your backups aren't good, but also risking your uptime, which would hurt your kind of ranking in terms of people connecting to you also. So yeah, it's a interesting challenge. Anyway, yeah, that was just one question that came to mind as we were talking about all this.
I was kind of curious if anybody, and coincident enough, we're actually on this slide already. Could anyone maybe explain to me the parts per million thing in a different way, whether that's Bosch or anyone who's willing to? That was one part of the chapter that kind of confused me. This whole idea that you have the millisatoshis, and then can be further divided down into ppms.
Yeah, so you have 2 fees. So you have your fixed base fee, which is just like represented in like MSATs, which all nodes kind of have. I think it's usually set at like 1 Satoshi or like 1,000 Satoshis or something like that. But the variable fee rate, so that's based on how much. So when a payment gets routed through your node or through your channel, it's variable based on how much money's coming through. So if you have your variable fee rate, which is shown in ppm, you probably could show it in other ways, but it's generally pretty small numbers. So if you route like say 1 million Satoshis and your variable fee rate is set to 1, which is set in parts per million. So you would get 1 sat for routing 1 million Satoshis, if that makes sense.
Yeah, that does. Okay, so that makes the math a little bit easier. So 1 million sats at 1 ppm would be a routing fee of one sat.
Yeah.
And then if we moved those decimal places over, say, like, I guess one, I'm probably going to do some really pathetic math on a recording here. But if we moved the decimal place, over to, like one place, then we would also be, if we moved the decimal place over on the amount of sats that we were sending, we would also be moving the decimal place over one on the total routing fee, which would then take us into the millisats territory.
Yep.
For the actual routing fee. And I think the way I understand it is that the routing fee when you're closing has to be, like, you essentially have to round down because there's no such thing as a millisat on chain. So I guess as a node operator, you're just, you're incentivized to keep collecting these routing fees and millisats. And you're always going to be, if you decide to close at any moment, it's always going to get rounded down to the closest sat.
Yep.
Okay.
Yeah, that's correct. Yeah.
Okay, thank you for that.
And something as well, like I wasn't aware completely, like when I first kind of started playing around with Lightning, is you can have like a variable base fee and variable fee rate for like your whole node, or you can set it on a per channel basis. So say if you have a channel that's like got a lot of large capacity, you can, which essentially is maybe more valuable for people because it can route larger payments. Maybe you want to charge a larger fee with that channel. So it can get like quite complicated if say if you have like, like 20 channels or more, and you have different fees on each. It become a lot of monitoring and playing around with fees and changing fees on each channel. But you can just set it like node wide if you want, which is probably an easy way to do it. But,
gotcha.
Yeah.
Hey, so this has been really good. Thank you, like, so much, Bosch, for like staying up so late in your time zone. Can everybody like give some like little emoji things for Bosch? And how do we do that thing on Jitsi where we make all the little emojis like fly in the air? Here, if I send a beer in the chat, it doesn't work. Sometimes we get on these calls and like you do the emoji and the little hand raise thing, and they just start floating in front of the screen. But anyways, I put a beer in the chat for you, Bosch. So I in about 10 minutes I need to sign off here. So I was going to go ahead and stop the recording, but I wanted to figure out, Bosch, if there was any final points you wanted to cover before I turn the recording off and open things up.
Like I was getting close to like finishing off the important stuff. There was a few other things like node management. Oh yeah, there was only 3 more slides, so I was pretty much done. The fees, which you kind of just discussed then anyways, was probably important thing. And then like the last bit is just pretty much showing some node management graphical user interfaces, which kind of show all that stuff that I just talked about graphically. But yeah.
Wonderful. So I'm going to go ahead and stop the recording there. Oh, yeah.
Well, something I think is interesting on the node management thing is that they are specific to they can be specific to the Lightning implementation. Like I think Ride the Lightning possibly works across multiple, but was it Thunder Hub is only LND. So that's just it's kind of an interesting aspect of Lightning that the different implementation also can differentiate how you manage it.
Yeah, very interesting. Okay, I'm going to go ahead and stop the recording here, and then I will post a GitHub issue later for the next one.